Hi everyone, my name is Kelsey Boyer, and today I'm going to demonstrate a science experiment for 5th graders that satisfies the NGSS Earth and Space Science Standards. Specifically, this is 5ESS1-2. So we are going to represent data in graphical displays to reveal patterns of daily changes in length and direction of shadows, more specifically times of day and night. So this is a really fun engineering project where students have to craft their own sustainable clock. So they're essentially making a sun clock, a sundial. And this is a really great way to also incorporate elements of social studies and culture and how before we had clocks, how did we tell time? So you can kind of show examples of historical representations of clocks and allow students to make their own as well. So there are a few supplies you're going to need in order to do this experiment. You're going to need, each student should get a paper plate. You're going to need your scissors, a template that is available online. I will link where you can get it below. So you have AM and PM, the 24 hours, and you'll notice that there's months of the year in between. So where students are going to stick their little dial depends on the month of the year on the middle piece right there. So you're going to need something straight. You can use a toothpick with some like Play-Doh, or I just think this is so easy because then students can take this project home and tape the little bended end of the paperclip right there on. You don't have to worry about sticky tack or glue or any of that stuff. You will need a little bit of a glue stick to get this onto your paper plate, and a marker because we need direction. We need to make a little compass so that we know which way is north, south, east, and west. And that's about it. Oh, and a flashlight. You're going to need a flashlight as well, because before we take this outside to see what time of day it is, we're going to simulate it indoors in a darkened room so that students can see why the position of the sun is important. For this part of the experiment, we logged on to Mystery Science to look at videos that ask questions about clocks. Because when we set clocks, we look at another clock to see what time it is. But how did they set the first clock? This is the question that was asked, and the students decided to think about things that were natural without technology for looking at time. They talked about how the sun means it's day and the moon means it's night, and that the sun and the moon move in the sky during different parts of the day. How many hours of daylight do we have?
24.
Of daylight?
12.
12! The sun is up for 12 hours. And how many hours is it dark?
Nighttime.
How many hours?
12.
12 and 12 is?
24.
How many hours are in a day?
24.
Yeah. So that's how, before we had clocks, the Egyptians were able to tell time.
We have. Just because you have 10 fingers doesn't mean it's the only way to count things. Different people have used different customs. For example, the ancient Egyptians, whenever they'd count, they'd use their thumb to count their finger segments rather than count each finger itself. Go ahead and count your finger segments using your thumb. How many finger segments do you have?
Check this out. You can count to 12 on your hand. Can I look at me really fast?
Yeah.
How many parts are there on each finger?
3.
Yep. So if you're counting with your thumb, 4 times is how many?
12.
It's 12. And you're counting the way the Egyptians counted long, long ago. You can count to 12 on one hand using the segments in your finger. That is why they split the day into 12 parts in the day and 12 parts in the night. Cool?
Yeah.
So after discussing the historical and social studies and mathematical implications of telling time with the sun and counting systems between what we know today and what the Egyptians used back in the day, we then started looking at time-lapse photos of the sun's position throughout the day and how it is just like that arch that we had seen in the last video about 12 hours of sunlight, 12 hours of nighttime. But all that we see from our point of view is the 12 hours of sunlight because the sun is on the other side of the world. We didn't just talk about where the sun is in the sky. We also talked about the shadows that are cast by the position of the sun in the sky. We discussed how you can't just look up into the clouds and say, "Up, it's 1 o'clock." You need a visual marker. There are no numbers in the sky like this picture suggests. So today we are going to make our very own clocks, but we do need a compass, right?
Yeah.
So now that we have made our sundials or our shadow clocks, we need to put them in the direction that we have created, north, south, east, and west. We need to point this north. So can you spin the compass to make it be exactly north? Keep going. Oh, you're almost there. All right. Right there. Okay. So get your sundial. See the N for north? Okay, Chance, pick up the flashlight and be the sun casting a shadow onto your dial. Do you see what's happening?
Mm-hmm.
So what is the flashlight?
The flashlight is the sun.
The flashlight is the sun. And what are you changing about the sun?
Its direction and the shadow's direction.
Yep, you're changing the position of the sun in the sky. So, do you see the two different times of day?
Yeah.
AM and PM?
Uh-huh.
Can you do me a favor?
Yes.
And can you position the sun so that it's 9 o'clock AM?
Okay. Wait, 9 o'clock what?
AM. You're doing it. Very good. Now what about 4:30 p.m.? You got it. 4:30. Yes, very good job. So this is how people told time. They could tell time using the sun and a dial like this. This was like the first clock before we had the technology to have it just be mechanical.
Wow.
Isn't that neat?
Mm-hmm.
Very good. Look at your clocks and tell me what time it is right now. What do you think? Estimate what time you think it is.
It's 1 on mine.
12:30? It's almost 1. It's not exactly, so it's 12 something. 12:45? Let's see. It's 12:48. So your sundial is pretty accurate. It's 12:48 right now. Very good job. High five. So to wrap up this lesson, we brought it back inside and discussed what we learned. The students shared that they really enjoyed being able to count to 12 on one hand, and that they thought it was really neat that that's how the Egyptians had decided 12 hours in the day, 12 hours in night. That is why we have hours in the day. They also discussed the importance of the position of the sun because it gives them clues about what's happening during the day. For example, one student said, when the sun comes up and it goes through my window, it wakes me up. That tells me it's time to get up and get ready for school. And then when I come home from school and the sun's now on the other side of my house, I know that it's almost time for dinner. And when it's really getting dark, I know it's time to brush my teeth and go to bed. So while they're not looking up in the sky and saying, okay, the sun is at 40 degrees east, it is time for this, the brightness and intensity of the sun does give them hints about what time of day it is. And that's just kind of a natural inclination that we have. But now that students understand the importance of the sun and how that really helps us figure out time, and it was how we told time historically. Lastly, I really want to direct everybody to mysteryscience.com. That's where I got the greatest information for this project. and they have great resources for NGSS lessons.